I've been a Java evangelist, and for me, the embedded world is where you can actually really have a lot of fun. It's just unbelievable. I mean, the more I play with it, the better it gets. There are some weeks that I just play with Lego, and I'm like, oh my God, I'm playing with Lego, and then pay me for this. So it's just amazing. So anyway, so what we're gonna do today, first let me ask you a kind of silly question. How many of you are Java developers? Okay, everybody. How many of you are embedded developers? Raise your hand. So that's one of the main points that I wanna have, that I wanna express today is, if you're Java developers, there is nothing stopping you to become an embedded developer. So before, if you studied Java ME, it was like a different platform. It was like, you know, this little thing that we have that run on, you know, low power devices or the old phones and stuff like that. Now with Java 8, what we did is we actually make sure that the platform is aligned. So Java ME, it is the same, it's aligned with the Java platform. The Java VM that runs on ME is aligned with the Java VM platform. So we have a very good alignment of the platform, okay? Generics, now we have generics on Java ME, okay? So we're talking about pure Java now available for embedded, okay? You're just unaware there is one cool API that allow you to, in this case, in our case for today, connect to really cool stuff, all the peripherals. Sensors, light, switches, okay, all that. So that's the whole idea. You really do not need to learn anything new to become an embedded developer. You're a Java developer, you're ready. You're just unaware of the APIs. But what is an API? You just download it, get the APIs documentation, and then you're ready to go. It's just Java, okay? So today what I have is, we're gonna be playing with the Raspberry Pi. And the good thing about the lab is I will do a small introduction, a few slides about the code, how things work, and then you're gonna do the job, okay? So this is when they pay me for watching you work, okay? So this is awesome. So we have the Raspberry Pi. How many of you seen a Raspberry Pi before? A lot of you, okay. So this is a really tiny computer that we're using right now for this kind of exercise. The only reason we are using it, one, is very common and well known nowadays. It's very cheap. I don't know how much it is here in United States. In United States, it's like $35. So pretty much everybody can have one, and then you can have a lot of fun connecting things to it. Okay. So we have an SD card, and I think Colin did an amazing job, you know, emailing everybody. Letting them know what we have. So the Raspberry Pi boot up from the SD card. So on the SD card is where we have the operating system. We have a flavor of Linux called Raspbian, okay? We're gonna have Java ME on this device, and then we're gonna do cool stuff. So each of you later on is gonna get a box. The box has a USB cable for powering the Raspberry Pi, okay? Just connected to the Raspberry Pi, and the USB goes to your computer, so that's how we're powering the Pi, okay? For talking to the Pi, we're using an Ethernet cable, so we have a crossover cable. We're using a static IP address, and again, we're gonna have a document that Con will explain what it is, I have no idea. So we will have we're gonna follow a document that explains you everything, like the IP address, username, and password, and everything. Pretty much we're talking to the Raspberry Pi with the crossover cable. It includes the SD card. We do have LED, so lights are always good. So we're gonna turn on and off a light. For the LED, we do need an internal resistor, so we don't burn it. This LED already has the resistors, okay? So if you're gonna do it at home, remember that you cannot connect the LED straight to the GPIO pins of your Pi. You do require a resistor. This one is kind of hidden inside, so it's less thing for me to travel with. And then I solder the little jumpers here, so you can actually connect it straight to the Raspberry Pi. Where? We're gonna see, okay? And we also have, because lights are good but not good enough, we also have, each box has a sensor. Okay, in this case we're going to be using the BMP 180. It's a temperature and pressure sensor. Okay, so we can see the environmental temperature. You can put your finger on and you can see the temperature raising. You release the finger and then you can see the temperature going down. Okay, basically using GPIOs and I2C. Okay, both supported on the Raspberry Pi. Is anybody here electronic? Okay, don't hate me for what I'm going to say, but I'm a software engineer, but I love playing with toys, okay? So we're gonna see that there are many things that, as a software developer, you expect things to work. Like if I have a sensor, you expect to connect the sensor, and if it's a temperature sensor, you expect to be able to get the temperature, right? Well, no. Okay. So first of all, the Raspberry Pi, so this sensor is using I2C protocol, okay? So, and the Raspberry Pi has I2C support. Whoo, easy. Okay, first thing, Raspberry Pi has a blacklist. Yes, if you're in the blacklist, you don't work. Guess what? I2C is part of the blacklist. So first thing, figure out how to enable I2C, how to remove it from the blacklist. Then you say, okay, I'm ready. Connect things, get the temperature, nothing. Okay? So very interesting. Some devices are on a sleep mode. Okay? So you have to wake them up to be able to get the temperature. Okay? So very interesting. This one over here, different sensor. You need to wake him up, write zeros in a particular registry to be able to get some reading. This one, completely different. This one, it has some calibration data. So there is a huge amount of code to get the calibration, okay? Once you get the calibration, start it somewhere, get the temperature reading. Guess what? That temperature reading doesn't mean anything unless you apply a magic formula using that calibration data, okay? So we're gonna see, the code looks really big, but it really depends on what sensor we're using. Normally, that sort of things like calibration that you need to do, or the algorithm that you have to apply to the raw data that you're getting as a temperature and all that, normally is provided with the documentation of the device that you are using, okay? So again, as a developer, it was a little frustrating, but you kind of get used to it, okay? So, yeah, a lot of the time is, for me, the longest is finding out how these guys work. Because connecting to I2C, reading or writing from Java is piece of cake. It's just understanding what do you have to read, what do you have to write. In this one, you have to read, you have to write on a particular registry before you read the temperature. So every time you're gonna read the temperature, you have to write and say, I'm reading the temperature. So things like that. So again, it's not the same thing for each sensor, kind of everybody is different, okay? So just be aware of that. It's a lot of fun, but sometimes writing the code is the easier part. Understanding the device that you're using, at least for me, is what takes the most of the time, okay? Again, a lot of fun. Have your own Pi, so I'm prepared for you too. So I have extra cables, crossover cable, extra powers. I do bring extra LEDs. Even though this looks like a normal LEDs, they do have the internal resistor, okay? So there are special LEDs that I found somewhere in Amazon, okay? So we have the jumpers for this one. Just plug it in here. Just make sure you remember which one is the positive, which one is the negative, and then the other side go to the Raspberry Pi, okay? So if you own your Raspberry Pi, when we distribute and we do the lab, just make sure you get cables, you get one of these is enough. If I ask you not to separate them, because for me it's easier to carry this as a group of 5 rather than individual. So remember, I'm doing this around the world, so the easier is for me to carry, the better. And I also have extra sensors for those that brought their own Raspberry Pi. So again, the little one is the BMP 180. There is a big one. How many of you did a course online that Oracle has? It's called the MOOC. Okay, good. So if you did the MOOC, pretty much the lab is going to be very familiar for you. So I do encourage to get one of the big ones. This sensor right here includes a BMP 180. So include the temperature and the barometric pressure that we have here, okay? But also include an accelerometer and a gyroscope, okay? So I do encourage you to get one of the big ones. I also have another accelerometer and gyroscope. I do have the code, on my blog. So if we have internet access and you want to play with this one, you're also welcome. And I also have, I actually only have one, a light and color sensor. I haven't played with it, but it's a good exercise. You feel free to use that one. Okay? So again, there's nothing new. I'm just gonna talk about the device access API, that little piece that you need extra to be able to become an embedded developer. If you play a little bit with the Raspberry Pi, you might know that on here you can have Java SC embedded or Java ME embedded. Okay? So big question, which one do you choose? Okay? And the answer is easy. It really depends what you're trying to build. Like for example, last year for Java 1, I created my own tablet. Okay, so it has a screen and it was powered by a Raspberry Pi. So for me, as a tablet, it was key that I have user interface. Okay, so if I need user interface, I need APIs that support user interface. In this case, I wanted to use JavaFX. So if you are planning to create an application that do require user interface, you need to go for things like Java SE embedded that has support for JavaFX, okay? But Java SE as it is today does not include an API to access peripherals, okay? So access into sensor GPIOs is not part of it yet. We're planning to include it, but it's not there yet, okay? So for me, the user interface was the most important thing. So I ended up using Java SE embedded with an external library called Pi for Java. Java ME embedded include the device access API, is what we're gonna see today, that has everything to connect to peripherals. The good news, the device access API is gonna be part of Java SE embedded. Okay, so Java SE embedded will have both things. For the lab, we're going to be talking, first exercise is using GPIO, second one is using I2C. The document itself started with the emulator. I do encourage you, create the project, follow the instruction with the code, but do not run it on the emulator. Leave that as a homework. You can do it at home. You don't need a device. You don't need sensors. Go straight to run it on the device, okay? For the presentation, so probably you've seen this slide many times. So what we're looking into is Internet of Things. We move from the host area, PC area, where everybody has their own PC, and we're really moving into millions of things connected, talking to each other. So unless we use the standards and we all talk the same language, it's gonna be very hard to do so, okay? And that's the power of Java. Okay, Java is a well-known use. So when I talk to developers before, I try to talk about Java ME. The first question or the first issue that they present to me was, we do not have time to learn something new. We don't have the time. I don't want to learn new APIs. So the good thing is with Java ME embedded is the same Java platform. So you can start being productive right away. There are many things important on the embedded industry. So think about it, how many embedded devices there is out there, okay? Some of them have different operating systems. Some of them don't even have an operating system. So thinking that you can actually write one application and being able to run anywhere is really powerful. okay? Managing your application in a remote way. So think about it. You're sensing the environment. So you distribute a bunch of sensors in the Amazon jungle, okay? And they are collecting information about the environment, okay? Of course, you're gonna change your code. You know, there is new requirements, something changed, you wanna improve it, whatever. You cannot think about sending your developers back to the Amazon, collect all the devices, reprogram them and put it back, okay? So having a remote way to be able to monitor those applications, restart, stop those applications, redeploy those applications, uninstall those applications is key, okay? We're gonna see how in JavaMV Embedded we have the application management software that allow you to do so. Today, we have the computer and we're just gonna say run. And NetBeans will compile the code and it's actually able to transfer to your Raspberry Pi and start your application, okay? Right away just by saying run, okay? We're gonna have an emulator that allow you to visually see what is going on this device, okay? So you can see if your application is running, is not running, etc. Okay, so it's very, very cool. So this is where we're gonna focus today, the device I/O API. So this is very familiar for JavaME platform in the past. We have a configuration, and on top of that, we have a profile. The configuration that we're using is the connected limited device configuration. It's the basic platform that we need to run our application, and it does include the Java VM. Okay. On top of that, we have the JavaME embedded profile, or MEEPA. Okay. We have extra APIs for connectivity, generic connection framework, for devices, and for security of the SATSA. And on top of that, we have a bunch of optionals API. But today, the guy is the device I/O, okay? Now, very generic way, we're going to connect to peripherals. Okay, for those who took the MOOC, okay, can you raise your hand? Okay, do not hate me for what I'm going to say, but if you take the code that you built for the MOOC with the release that we have today, it is not going to work. And what happened was, when we did the MOOC, we have the pre-release version. Everything was called peripheral, okay? For some reason that I'm not aware of, for the release, they changed everything from peripheral to device. So it's very easy to update. Just make sure that whenever you see peripheral, you change it for device. So if it's peripheral manager, they rename it for device manager. Peripheral exceptions, device exceptions. Peripheral configuration, device configuration, okay? Everything that was called peripheral now is device. Easy to change. And also they changed the name for the packages, okay? Again, very easy, just look at the APIs, how they change it. Minor changes, but straight away your code won't work. And even frustrated for me because we're doing the course online again, and I have to redo all the videos and everything, so cool. So peripheral abstraction interface, so it's called device. We have support for GPIOs, I2C, SPI, WART, and all that, okay? I2C I think is really cool. My first time working with it was last year, and then I realized there are so many cool devices out there that use I2C. For example, the device, the Wii Motion Plus, actually use I2C. So I'm like, hey boss, can I have a Wii and I can just, you know, connect it to my Pi, and a good way to expense away. So anyway, there's a lot of cool devices out there that support I2C. As long as they have different address, you can all connect it to the same bus, okay? So very cool. Be aware, I don't remember if I did this yesterday. Sorry, I have to reflash all the SD card yesterday, so I went to bed like 2 a.m., just making sure everything was ready. Just double check. When you want to execute your code on a device, because we are actually having access to peripherals, in this case we need permissions to be able to execute. For the lab purpose, we can avoid that authentication by setting the authentication provided to null. So you'll have to include this line into the property files, okay? So just make sure, go to Pi JavaME, it doesn't have early access anymore, it's called JavaME 8, go to the binary and make sure that this property file has the no authentication, okay? If no, raise your hand and I will help you to just add it. So basically, we just need to add that line, okay? Device manager, so this is how we're gonna open a particular device. Important to notice, you can just provide an ID or a configuration. ID, for example, we wanna connect to the LED, okay? It's a simple output, GPIO for output, okay? When we don't have to provide much information, you just need the default, we can just say open and provide the ID. That is the pin where you're connecting that LED. But if you need to provide extra information, for example, you're saying, I'm connecting a switch, so this GPIO is for input. I want to listen when you push it and when you release it. I want to have an initial value of false, things like that. When you want to provide more information, you encapsulate that into a configuration object and you give it to the device manager to deal with it. Okay, so 2 ways to open a connection using an ID or configuration. Okay, all the devices implement the device interface. Okay, that's the way the device manager can connect to any of them. Okay, we do have listeners. So remember, for example, if we have a switch, okay, you want to listen when the user pushes and releases the switch, right? So we have a listener, okay? If we have a listener, we have an event. So we also have a device event, okay? And then we have a bunch of exceptions, okay? Make sure you release the device once it's done, or if the device was not found, for example, you plug it into a different pin, device not found exception, stuff like that. Very basic. Okay, for the hardware, we're using the Raspberry Pi. Important to notice is the pins that we're going to be using. GPIO, WART, SPI, and I2C is what we have. Going to be using GPIO and I2C for the lab. Okay, and just general information about the specification of the Pi. Now, I did all the configuration for the SD cards here, and I think if you brought your own Pi, you already did this. If you need information about it, let me know. We have Stephen Sheen documented all the information about configuring the Pi, and I documented also enabling I2C on my blog. So everything is available online. You don't have to do it today. It should be already done for you. Okay? On your computer, we're gonna be using PuTTY to connect to the Pi. We're gonna be using JavaME SDK 8, and this is the one that provided with the emulators. Okay, so very cool to have, and then NetBeans 8. Okay. Just gonna skip this one. Okay. Now, first code, extremely difficult. 2 lines to turn an LED on. Okay. So we're gonna say device manager.open the pin where you plug your LED, and then you're gonna say set the value to true. That's all you have to do to turn the LED on. It couldn't get any simpler than that. Okay. Now, pins. Some platform group the pins into ports. Okay. So you also have the possibility of managing the GPIO port. This is specific for the platform. So for example, at the end of the documentation of the Raspberry Pi, you will see which pins are associated with ports. So I know, for example, GPIO 17 is associated with port 0. Again, this depends on the platform that you're using. Just look at the documentation. If you're using a port, how you do it, you open, you provide the port number. For 8, you actually do not need to specify this casting, okay? We have generics now. So type inference given for JavaME, okay? And again, setting the value is the same. Just set the value for all the pins in that particular port. Simple, huh? Yes? Okay. Now, for the pins, unfortunately, I do not have switches, because I mean it's so much that I can carry. But just for you to know, then a switch, a GPIO pin, can be for input or for output. Output, we're talking about a simple LED. Input could be a switch. If you have an input GPIO pin, you can register the listener, okay? So you set the input listener and provide who is gonna be listening for any incoming events, okay? To remove it, you just set the input listener to no. So very straightforward, like we use listeners on Java. This diagram I included in the document. I can't live without it. Look at this. So this is what I cannot see the colors very well. Okay, it has colors originally, okay? This is, the GPIOs are green, no orange. We have I2C is purple. So, okay, they have different colors, but the whole idea is, this is like a sum of these pins. If you count them, 1, 2, 3, 4, 5, pin 16 on the Raspberry Pi is GPIO 23, okay? There is no easy way to remember this. I keep this handy. So the ID of this GPIO is 23. But if you count it, it's the pin 16, okay? So be aware of that difference. This is the one you're gonna be using for your code, 23, 24, GPIO 25, okay? First part of the code, we have an LED. Remember the resistor, in this case it is included. So even if you don't see it, remember it is there. We connecting one LED to 16, the other go to ground. And in this side we have a switch, also with a resistor. The switch is actually controlling the LED, okay? That's what we're trying to do in the code that I'm gonna show you, because that's your first exercise, okay? So remember how to connect to a GPIO. You say device manager dot open and then the ID, in this case 23. Extremely simple. For the switch, we have device manager open and we provide a configuration. Okay? This configuration is specifying port, pin, that is only input, that we are listening to both edges, raising and falling, so when you push it and when you release it, and the original value. You encapsulate that into a configuration object and give it to your device manager. Again, you don't have to do the casting, okay? Then we want to listen, so bottom set input listener to this. Okay? The pin listener interface, one method, value change. Whenever you got an event, make sure it comes from the bottom. What you're trying to do is the value that you want for your LED is whatever you had before, the opposite. Okay? So we just, if it's on, we turn it off, and it's off, we're gonna turn it on. Okay? Very simple first exercise. Turn it on and off your LED. Some people do a separate thread so that they can be blinking, the LED, so just have fun turning on and off LED. Should I do the demo now?
If you want to set the images up, yeah.
Okay, so I'm gonna do the demo and then we're gonna split. I don't wanna give you everything at once. I want people to start playing with the code. So what I have my Raspberry Pi. It is already connected. Okay, first thing that we do, oh, hold on. Oh, okay. Okay, good. Okay. So what we have, I just open PADI, connect to my Raspberry Pi 10.0.0.37 is the IP of the Pi. Okay. In your home directory, there's a Java ME, so you go to Java ME. Again, all this is in the document. Okay. Inside the Java ME, you have a bin directory. In the bin directory, you see the properties files. Okay. So see how somewhere I have to have the null authentication. I just don't see it. Okay, somewhere it is. Okay. Now, run user test as a sudo. We need we need root permissions. Okay. So you see that Java is starting on my Raspberry Pi. Once I have Java started, I can connect. I'm actually going to disconnect so I can do it again. Okay, let me remove it. Okay. So if you install Java ME SDK, you come to this icon here. You have a little icon that looks like a phone. Okay, it's this guy over here. Okay, you click to it. You add a connection so we can see the Raspberry Pi. Provide the IP. Okay, just verify that it said that it's connected. So that means we can see the Raspberry Pi. The Java ME on your machine can see the Pi. Okay? Again, don't worry about it. The documentation has snapshots and take it step by step. I just want to walk to you so it's easier. Now I have a code. It's a door project. I have an LAD. It's what we saw. We have an LAD 23. This may be more complex than we really need it, but we have the device manager.open providing the ID and setting the LAD either false or true. Okay? We have a method for setting the value, getting the value, and I have a blinking method. Okay? So I want to blink the LAD, so we put it in a separate thread. Okay, so we don't block. And pretty much we are blinking X times multiplied by 2. So a full blink is on and off. And you just set the blink. You set the value to the opposite of what you have. Okay? Then we have a complete project. That is, in my case, I have 2 LEDs and a switch. So what I want to do is I have a door sensor. So when the door is closed, the green LED is on, just to say everything is fine. If the door is open, red LED is going to blink 3 times, warning the door is open. Okay, so that's what I'm trying to show here. Okay, so here I have the switch. The switch I connected to the pin 17 that on the Raspberry Pi is port 0. Okay, I have 2 LEDs that we just saw, green and red. Okay, I have the constructors for the LEDs. Okay, and new we have the configuration. We already saw this. So I have the configuration for my switch with the port, the pin, listening to both edges. Original value is false, and it's actually for input only. Okay, exactly what we saw for the switch. Device manager.open using that configuration. Set the listener, so we listen to any change. And then on value change, we just make sure if the door is open, okay, we blink the red LED 3 times, and we turn the LED, green LED off. If the door is closed, we turn the green LED on, and we turn the rest off. Okay, so very simple, pretty much the same code, just putting it together with a switch and just taking turns. Now, when you come and when you build your own demo, okay, you create your project, you can right click and go to properties. In properties, you have the platform. This is where you want to run your code. So you have the emulators, that's the embedded device 1 and 2, and you have the external device. This is my Pi. Unless you connect it to the phone that we saw originally, you wouldn't be able to see it. So make sure you connect it using the phone right here, the manager, so you can see the external device. Okay, so what I'm saying is I'm gonna run on external device. NetBeans will compile it, send it over, and start execution. Okay, so say okay. Now I can run, I can hit run. So emulator is gonna get started, hopefully. Remember, this is just showing me what's happening on the external device. is telling me the door project is running. And we can see here by default the door is closed. If I press the button, we just change it and we blink the red LED, then leave it on, and then if I release, it goes to green again. Okay? So first exercise is to be able to successfully connect to your Pi, okay, using Pi. Go to here to the manager, to the device manager, add it so you can connect to it, follow the step, create your project. To the first exercise, it's very simple, turn the LED on and off, okay? Remember, the code was meant to be originally the first part for the emulator, okay? So think about, you're not using a switch because you're going straight to the device. So the code that you have, modify it for one LED. Turn it on and off, or do a loop, turning the LED on and off a couple of times, okay? And be able to run it successfully on the Pi.